We are going to start the lecture on international system of measurement. Why we need this system of measurement? The main use of this system is that when we multiply one quantity with another quantity, so we can get the unit of the third quantity. Let's suppose the unit of area can be calculated with the help of the formula that is length multiplied by breadth. The unit of length is meters, while the unit of breadth is also meters. So meter multiplied by meter will be equal to meter square. So that is why the unit of length is meter square. Now, therefore, when we are studying the international system of measurement, we must be familiar with the type of physical quantities. Basically, we have two main types of physical quantities. One is base quantities, or we can say fundamental quantities, and the second quantity is named as derived quantities. So what happened? There are very small number of base quantities. The number of base quantities are seven, while there are more than 300 derived quantities which are derived from the base quantities. The first best quantity is we have the first base quantity is length, and the unit of length is meters, as we have discussed above. Then we have mass. The unit of mass in SI system is kilogram. Then we have the third best quantity, which is time, and the SI unit of time is second. And the fourth best quantity is the amount of substance, and its unit is mole. And then the fifth base quantity is electric current, and its unit is ampere. The sixth base quantity is temperature, and its unit is SI unit is Kelvin. And last but not least, base quantity is luminous intensity, and its unit is candela. So their units are based unit, fundamental units, their unit of length, mass, time, amount of substance, temperature, electric current, and luminous intensity are not derived. Now let us discuss the derived quantities. So now, what we say, first of all, if we want to go to velocity, so what if the formation for the velocity, it is a derived quantity, and velocity is defined as displacement over time. So what if the unit for displacement, if displacement is a length? So length is measured in meters, and what if the unit for time, this is second. So the unit for velocity is meter per second. Now let's go to the next quantity, which is acceleration. What is the formation for acceleration? So nothing but it is equal to velocity over time. As discussed earlier, The unit of velocity is meter per second. So we can show meter by m and second by s. When we divide it a next second s, that second will be multiplied by second. So the unit of acceleration is nothing but that equals to meter per second square. Now coming to the next quantity, we have force. The formula for force is mass multiplied by acceleration. So here, unit of force can be derived as the unit for mass is kg, kilogram, and the unit for acceleration is meter per second square. And this complete unit can be defined as the unit of force is Newton, because Newton was the scientist who gave the complete concept of force in inertial frame of reference and in moving bodies. Then the next quantity which we have, that is work. The formation of work or work can be formulated as force multiplied by displacement. So if we have discussed, now the next quantity is work. So work can be defined as force multiplied by displacement. So is the next quantity is work. It can be defined as force multiplied by displacement. So the unit of force is kilogram into meter per second square, while the unit of displacement is meter. So meter is multiplied by meter. It will be equals to kilogram into meter square per second square, or the unit of work can be defined as kg into meter per second, as discussed earlier, is kg per meter, kg into meter per second square is defined as Newton. So it is Newton meter, or we can define work in SI system of unit as joules, if it is the name of the scientist. Joule was the scientist who calculated the heat work done in the thermodynamic system. The next quantity is power. The formula for power is force multiplied by velocity. So therefore, power, the unit of power can be derived. Therefore, the unit of the power is derived as the unit of force is Newton, and here the unit of velocity is meter per second. Or we can also describe accordingly with Newton, kg into meter per second square will be multiplied by meter per second. So this will be calculated as kg into meter square per second cube, which is equivalent to watt. Therefore, power can also be calculated in a watt meter. It can also be uh, converted by using the kilowatt and horsepower, but the SI unit is in watts. Now coming to the next quantity, which is energy. Energy is the capacity to do work, and the formula for that is power multiplied by time. So that's why energy will be equals to power is watt time is second. So it is usually measured as watt second, or it can be calculated as kilowatt hours, which is the unit of electrical energy. In our home appliances, the bill comes in accordance with the kilowatt hour consumption, and that is defined in how much kilowatts one has consumed in 1 hour. That is the one unit of electrical energy. Now, moving ahead, we can say that energy can further simplified as we know that power, so power is equal to kg into meter square per second cube. We will be multiplying it with time. So this will give energy will be equals to kg into meter square per second square, because 1 second is cancelled with second cube, so second square. So the unit of energy and work is same, and they both can be calculated in joules. After that, we have another quantity, that is momentum. Momentum is defined as mass multiplied by velocity, and the unit of momentum can be calculated as mass is kg multiplied by velocity is meter per second. So it is kg into meter per second. But if we can calculate as, so we know that in accordance with force, the unit of force was kg into meter per second square. So the unit of momentum is kg into meter per second. If we will multiply and divide by second, so we can simply multiply and divide by again second. So we can get kg into meter per second square multiply by second. And this second is in the numerator. So this is equals to Newton. So Newton second is also the unit of energy. Newton second is also the unit of momentum. So these were all the drive quantities which we have discussed in this lecture. Now we will be discussing the main difference of, now now we will be simply discussing that there are so many quantities, almost more than 300 quantities. So the file will be attached in which all the units of drive quantities will be written on that page. So now homework. Now assignment for this lecture. Drive the units of A, elasticity, B, stress, C, pressure, and D, part 1 charge, part 2 flux, and E, magnetic field of induction. You will be credited for this assignment. Send on the email which is attached. Thank you so much.